Hi everyone, it's Dr. Goyle here, and I wanted to share with you a really interesting article that came up and just something coming up from my workday, and I thought this is something that you'd find interesting. Basically, the effect of study that's come out in Aging Cell of the effect of physical activity and its effect on slowing epigenetic aging. I know that's a mouthful. Let me take you through this a little bit and see if you can take home some useful points from this article. So here I have it up on the screen here. Again, in Aging Cell, physical activity associated with slower epigenetic aging, and this was basically a cross-sectional cohort study with over 3,500 eligible participants, mean age 55 years of age, and they followed these patients, tracking how their activity levels. They were using an accelerometer, so like they were a little device that they were like on their hip that would tracking their number of steps, and they could calculate out their activity levels and then measure their aging, their biologic aging, looking at the specific epigenetic aging markers to see what was the association between that. So let me take you a little bit of background first. We do know that physical activity does give you decreased risk of age-associated diseases. So, for example, decreased risk of heart disease, decreased risk of diabetes, decreased risk of other chronic diseases, and it leads to increased life expectancy. So you live longer, and you have better quality of life. And we know that this is because of the changes that happen with exercise. Like if there's physiological changes, people generally have less weight. There's biochemical changes that happen in your body, and the way genes are transcribed also changes when you exercise. So we think this is what underlines how physical activity provides benefits to your body. And then we also know now from various studies is that exercise changes the way the DNA gets methylated. This is called epigenetic changes. So on top of the DNA, there's certain sites called CPG sites that either get an extra methyl group or lose a methyl group. And how this DNA, whether or not this DNA gets this methyl group or not, changes the way the DNA is expressed, whether the genes are read or turned off and on. So that's why DNA methylation has become really a very good way of understanding basically aging. And there's been a number of now what we call these aging clocks based on DNA methylation that basically tell you your biologic age. And in this study, they were able to show that physical activity had an influence on slowing the epigenetic age, and it looked to be related to the effects on slowing the aging of the immune system, as well as slowing the aging of the cardiovascular system. We do know that aging of the immune system is one of the mechanisms of aging, and we also know that cardiovascular aging is a major has a major impact on aging. The interesting thing about this study, let me see if I can just take you over to some interesting parts of it. The first part I wanted to just mention is that there was a note here that what they found was that the people who were the most sedentary and began exercise had the greatest amount of slowing of aging. So as people who are especially sedentary or have less activity are going to benefit the most from adding some exercise. Not saying that those who are already active aren't going to have benefit. It's just that if you're starting from like very low, like 0 or 5 or whatever out of 100, and you increase to 20, you're going to have a huge jump in the benefits from that activity. So what the other thing that they've noticed is that looking at the aging of the cells of the cells, primarily the genes that were affected by the physical activity were those genes that were related to the vascular endothelium. So it means that the lining of the small blood vessels, the genes that influence that, were greatly impacted by physical activity. It also appears that genes that were responsible for neuronal pathways and brain health were also impacted by physical activity. So that's another mechanism for how does physical activity impact aging. Appears to be through the cardiovascular system, improving the vascular lining and improving brain function. They also noticed that the physical activity seemed to also have impacts on those parts of the DNA epigenetic markers that were related to immune function. And we do know that exercise does slow down immune aging, and it looks like in this study they were able to confirm that there was association between those who exercised more and slowing down of immune age. So there seems to be less inflammation, which is when you have a younger immune system, you have less inflammation. You'll have increased neuroplasticity. And with the cardiovascular effects, they feel that from the study, they believe that this was mediated through improvements in blood pressure, decreased weight, and improved triglyceride levels. So in a nutshell, what's the bottom line here from the study? Bottom line of the study is that we finally have a good study that actually was recording people's activity and then measuring their biologic age. And they found that people who exercised more had a slowing of their biologic age. This appears to be mediated through improvements in their cardiovascular function and their immune function. So I hope this was helpful. And another reason for you to go out there and exercise, at least in this study, they were looking primarily at steps. So just walking has impacts on your biologic age. All right. Have a great night. Take care.